Hi, so my name is Chaitanya Sahu and my roll number is 575. The title of our project is HydroSense and we are team 6.
I am Vinay, my roll number is 578.
I am Shrikar of roll number 582.
I am Shrija of roll number 583. I am Srivarshini of roll number 586. We have done this project under the guidance of Suresh Ram sir, HOD, Ravi Nayak sir, Ravi Kiran sir and G. Ramesh sir.
Okay, let's go with the introduction HydroSense. So traditional and current irrigation practices in agriculture often result in inefficient usage of water and leading to both the crop wastage and the water wastage. So crops such as paddy require precise of water management to avoid the damage from excess water. So to address these challenges, there is a need for an innovative irrigation system which automates the water management system, and it optimizes water usage based on crop needs and minimizes the water wastage. So this promotes sustainable agriculture practice.
So what's the issue here? There are mainly two issues. One is wastage of water and other is not having a good crop yield. So let's come to the first issue, which is wastage of water. If there is excess of water than what is required for crops, then that leads to wastage of water. But when there is lesser water compared to what the crop actually requires, then it leads to lesser crop yield or improper crop yield. This leads to the loss of farmers. So our main stakeholders or the main users of this project are farmers, agricultural fields, farmers of agricultural fields. So yeah, what do the users require? The users require water should not be wasted and they should get a good yield. So after getting a good yield, they will get good amount, good price for their crop. So to address these two issues, we need two systems. One is water management system, one is good crop yield. So these two can be integrated into a single product or single project in which we will maintain the water level at a particular level. If the water is more, that means water is being wasted, then we will put the water back to the tank. And if there is lesser water, then we will put the water from tank to the field. So in this case, crops will not be spoiled and water also will not be wasted. And next coming to the existing systems. So I will talk about mainly two existing systems here. First is soil moisture sensors. This has come into use very much recently. So this soil moisture sensors are kept into soil and these measure the moisture levels of the soil in any weather conditions. So during this, if there is enough moisture level, irrigation method is not started. If there is not enough moisture level, then the irrigation is started. Water comes into the field. These are okay, good, but not up to the mark, because even if there is some moisture content available, the water will not start. So we need a particular certain level of water. For that, we have to use water level sensor. Now coming to the second existing system, which is drip irrigation. Drip irrigation is good for some sort of plants, but not good for some crops like paddy, which require more water. So in drip irrigation, we have long pipes with holes in them, and when the water flows through it, water drop by drop water comes out through those holes, and that is how irrigation is done. So drip irrigation also won't work in this.
Now I am going to tell about the proposed solution. The proposed solution is to provide an automated water management and irrigation control system. These can be achieved by using water sensors to detect the level of water in the field. A water sensor will be set at a particular level in the field. If water reaches this level, then the water motor will automatically be turned off. Another water sensor will be used to detect if water level is exceeding the safe limits. This will remove the excess water from the field until it reaches the safe level. By this, there will be little to no water wastage and the crops will also not get damaged due to excess water.
So components used in our project are Arduino, water level sensor, two motors, two relays, connecting wires and pipes. So our main heart of the project is Arduino, which takes signals from the water sensors like water level sensor and it gives the output signals to the motors. And our other main component is water level sensor, which detects it continuously monitors the level of the water in the field. It signals the if water level is above the threshold level, it signals to the Arduino, and Arduino will on the desired motor in the field, and the motors are used for the inflow and outflow of the water, and the relays are used for the control of the motors. Thank you.
Okay, I am going to explain about working model of the project. In this project, we are using two motors. One motor is kept in the field to water out, and one motor is used to kept in the tank to in the water to the field, and another we used water level sensor to detect the water level in the field, and we can set the threshold value according to our needs and requirements. We can set that, and if water level is reaches to the above threshold value, then this motor is on and the water will go to the tank, and when the threshold value is less than we can set this motor is on, and we are using Arduino and relays, motors and water level sensor.